Harvard scientists may have just discovered the first effective treatment for Alzheimer's disease. That's a bit too much. Let me try again. Harvard scientists have just discovered a mechanism that may lead to the first effective treatment for Alzheimer's disease. Better. That's fair. My name is Dr. Robert Duff. I'm a neuropsychologist, and I work with people that have Alzheimer's disease on a daily or at least weekly basis. So any research that involves Alzheimer's disease, especially stuff as promising as what I'm about to tell you, is very exciting for me. The research here is dense, but I want to nerd out and get into the details with you. I'm not joking when I say that I was glued to the research like it was a fiction book that I couldn't put down. The design was so elegant, and the quality of the research was great. The results, though, bonkers. So this is going to be a pretty long one. I'm going to give you the TLDR beforehand so that you can get the full highlights of it. But I really encourage you to listen all the way through because this is really interesting research, and I think it's a good example of how to do great research at a time where there is some iffy stuff out there, as I've covered recently. So here are the highlights. The article is titled Lithium Deficiency in the Onset of Alzheimer's Disease, and this is in the peer-reviewed journal Nature. These authors were out of Harvard Medical School in the Department of Genetics, as well as Boston's Children's Hospital and the Rush Alzheimer's Disease Center. And this is brand new research published August 6, 2025. So cutting edge, brand new stuff. I'll link the full article in the description, as well as my full write-up of all the details. As the title may suggest, the researchers were looking to discover the impact of lithium on the brain. We have lots of different metals in our brain, even though it sounds kind of scary. And disruption of the homeostasis of those metals can have different effects. But they found some really, really interesting stuff regarding lithium. So here's the breakdown. They found that for people with mild cognitive impairment and Alzheimer's disease, they had significantly reduced levels of lithium in the parts of their brain that are impacted by Alzheimer's disease. Lithium was highly concentrated in amyloid plaques, which are a key feature of Alzheimer's disease, and reduced in other areas of the brain, which suggests that amyloid plaques bind up lithium and reduce its availability elsewhere in the brain. Decreased lithium in the non-plaque areas of the brain correlated with poorer performance for both normal and Alzheimer's subjects, indicating that lithium is essential for cognitive functioning. Through a series of experiments using genetically modified mice, they very much confirmed that the binding of lithium is very, very pronounced in amyloid plaques, and that reduces the lithium available in other regions of the brain. They also saw the same exact change in cognitive performance that was observed in human subjects. By intentionally reducing lithium levels through modifying the diet of the mice, they were able to elevate amyloid and tau, which are both key in Alzheimer's development, and reduce cognitive performance, essentially generating those difficulties. They then discovered that lithium carbonate, which is what we use to treat bipolar disorder, tends to bind very heavily to amyloid, whereas a different lithium salt, lithium orotate, did not. So by administering lithium orotate to mice, they were able to prevent the buildup of amyloid plaque, increase lithium levels in non-plaque parts of the brain, and reduce the amount of amyloid plaque already present in the brain. Lastly, administering lithium orotate to mice also effectively reversed the memory loss that they already had because of the amyloid buildup. So together, all of this shows that lithium is very significant in terms of brain aging and cognitive performance. Low doses of lithium orotate, not the kind prescribed for bipolar, can actually preserve cognitive function, reduce inflammation, and suppress amyloid buildup in mice, which has huge implications on the research and treating of humans with Alzheimer's disease. So that's the broad overview. I know that's a lot. This study was long. You can look at the table of contents. There's a lot of different sections to it. I want to go through and give you some background on what you need to know in terms of Alzheimer's disease, also lithium, and then break down each part of the study design and tell you what you need to know from those things because, again, very elegant design. I think this is groundbreaking research potentially. So let's just dive into it. So first off, let's talk about Alzheimer's disease. Some of you already know about this, but basically what Alzheimer's disease is a neurodegenerative condition. It's a degenerative condition, meaning it breaks down the brain over time, and it's progressive. So it always ends with somebody getting dementia, which is when you have impairment that's so bad you can't live independently. And inevitably, somebody dies from complications due to that dementia. So it starts with short-term memory loss, nothing too severe, just kind of a senior moment here or there. You wouldn't consider someone to have dementia at that point. That's just sort of some quirks. Then it gets worse, and you would have what's called mild cognitive impairment, where there's certainly some difficulty there cognitively, but it's not so severe that it's really impacting the person's life. But then as it moves on, the short-term memory gets very bad, forgetting what they had for breakfast or whether they took their pills, missing appointments, forgetting the names of family members, forgetting to eat. And that's when you would say someone has crossed over into dementia that's caused by the Alzheimer's disease. So as the disease process eats away at the brain, it causes that dementia to happen. If you've ever known somebody with Alzheimer's disease, you know that the end stages are very much not pretty, which is why we want so desperately to have some sort of solution, some sort of treatment. So far, we really don't, though, which is why research like this is so easy to grab onto and just have a little bit of hope. Now, we don't know exactly what causes Alzheimer's disease. We do know that it causes a few hallmark characteristic changes in the brain, though. One of the biggest culprits is what's called beta amyloid. And this beta amyloid is an abnormal protein that clumps together and causes plaques. These plaques form on the outside of neurons, which are the cells that communicate back and forth in your brain, and that causes them to stop functioning and die out. Inside the neurons themselves, you also have a protein called tau, and that gets twisted into what are called neurofibrillary tangles, and that interrupts the flow of nutrients within the neurons, again, causing them to die out. And so with this, the plaques and tangles, they cause these cells to die, and that causes shrinkage or atrophy in important parts of the brain, like the hippocampus, which is largely responsible for memory functioning. There's other stuff that goes into it. There's also evidence that Alzheimer's causes inflammation in the brain and changes in terms of how the brain uses energy. The immune system in the brain also seems to go into overdrive to try to compensate for the damage caused by Alzheimer's pathology. Basically, Alzheimer's creates a perfect storm of issues that slowly causes someone to deteriorate over time, and then, as I said, die from the complications. This often happens within a decade. So researchers, they've made huge strides in terms of understanding what's happening in the brain with Alzheimer's, but we don't really know what sets that in motion, and we haven't found any effective treatments, as I said before. So this is where we want to talk a little bit about the star of the show here, lithium. Lithium has a very, very interesting background. If you've ever heard somebody say, oh, there must be something in the water, that applies very, very much to lithium. Lithium is a naturally occurring mineral, which is an alkali metal, and it's been used for many years in psychiatry as a mood stabilizer. So for people that have bipolar, for instance, it helps to keep the mood stabilized so they're not experiencing such severe mania. The discovery of lithium, though, is very fascinating. As early as the 1800s, doctors began to notice that certain areas that had naturally high lithium levels in their mineral waters reported lower rates of psychiatric hospitalizations and suicides. So doctors ran with this. They created nerve tonics. They actually used to add lithium to 7-Up. And in 1949, there was an Australian psychiatrist, John Cade, who was doing research on mania using literal, I shit you not, guinea pigs. And he was mixing uric acid with lithium salts and injecting them into the guinea pigs. And he realized that the lithium itself made the guinea pigs become calmer. So then he tried using lithium carbonate on human patients, and the rest is history. We started seeing reductions in symptoms. And, lithium is scary in concept because it's a metal, it's an element, and it is something that can be very, very toxic in high levels. But throughout the 60s and 70s, research continued, and it became really the first true mood stabilizer on the market. And it's helped many, many, many people recover from bipolar disorder and other issues that required mood stabilization. These days, we have other options. We have atypical antipsychotics, for instance, like Seroquel or quetiapine, but it's still used. People still use lithium, and it's still very effective. Now, as I said, the something in the water idea is very apt for lithium because, funny enough, in modern times, in 2017, researchers from Denmark found that there was an inverse correlation between the levels of lithium in drinking water and the incidence of dementia, meaning the higher the lithium level, the lower the incidence of dementia. Now, this study was not perfect because it's a population study and it's observational. They're not giving people dementia, but it had a really, really big sample, and it was helpful to understand that there is potentially a link between lithium and cognitive functioning. So this, along with other preliminary research that people have done, led these authors from Harvard to kick off this study, which was, as I'm going to show you, very impressive. As I said, the study itself here is quite beefy, and I'm going to go through most of it but not all of it. There are some things in here that are going to be just too complicated on a neurobiological level to explain in a YouTube video, but I'll give you the broad strokes of that. And then a lot of the other areas I don't think are going to be too complicated for anybody to understand, hopefully if we break it down the right way. Now, study is a little bit of a misnomer because this is a series of studies that they did looking at different aspects of this. The first thing they looked at was lithium deficiency in people with mild cognitive impairment and Alzheimer's disease, right? So mild cognitive impairment being that middle point between normal functioning and Alzheimer's. So they hypothesized that there would be differences in the endogenous, meaning naturally occurring lithium levels between normally aging people and those with MCI, mild cognitive impairment, or Alzheimer's disease. What they did is they used mass spectrometry, right? So this is a lab technique where they can detect tiny amounts of metals in a sample. They use super hot plasma to break off charged particles, and then the spectrometer separates that and identifies what the mass of the different particles are, so you can tell exactly which elements are in there. And so this lets them measure like parts per billion, very, very, very small amounts of metals or whatever they're looking for. So with this, they looked at the levels of lithium in the brain in two different places. And this is with humans, right? We're not talking about mice yet. So they looked at lithium levels in the prefrontal cortex, which is very impacted by Alzheimer's disease. And then in the cerebellum, all the way on the opposite side, kind of near the brainstem, which is much less impacted by Alzheimer's disease. So the hypothesis being that there would be a change in the part that is impacted and not as much of a change in the part that is not impacted by Alzheimer's pathology. So they looked at all the different trace metals in these parts of the brain, and only lithium showed a significant reduction in the prefrontal cortex and not in the cerebellum, right? This means that the development of Alzheimer's disease seems to mess with the natural homeostasis and levels of lithium in the brain. From there, they took it a step further and they used a laser form of spectrometry, which, God, that's so hard to say, laser form of spectrometry. And that lets them analyze tiny spots of solid material without dissolving it first. So it gives very, very fine detail, almost like a chemical map of the brain. With this more detailed technique, the researchers were able to look at the effect of the plaques and tangles that happen with Alzheimer's disease on the balance of lithium in the brain. And they found that a significant amount of lithium was actually bound up in the amyloid plaques. And that caused a reduction in lithium in the regions surrounding that where there wasn't so much amyloid. This is a huge finding because it suggests that amyloid plaques effectively rob the other parts of the brain of its lithium. And we know that that's important because lithium seems to be important for cognitive functioning. So a very interesting finding, but what's the practical impact? Well, they looked at that too. Lower levels of lithium in the regions of the brain surrounding the amyloid plaque, right? So when the amyloid plaque absorbs the lithium and robs the surrounding areas of it, they found that people had lower scores on cognitive testing for episodic memory and semantic memory. Episodic meaning things that have happened, semantic meaning the meaning and the facts behind things, which are very common in Alzheimer's disease. So that concludes the human portion of this. What they were discovering from that, again, is that there's a difference in lithium levels in the prefrontal cortex versus the cerebellum in people that have Alzheimer's pathology versus normally aging populations, meaning you do see a shifting of the lithium levels away from those areas that are impacted by the disease process. The reason for that, they discovered, is that it's being bound up into the amyloid plaques, and the lithium is not able to get to the other parts of the brain. And when that happens, we're seeing in humans a reduction in their memories. Okay? So with that, we're going to move into the animal portion of the study where they're using transgenic mice, which means that they are genetically modified mice with human DNA in them, and we use them to serve as a proxy for humans. It's not perfect, but it's a great avenue for researching things. And so what we can do is we can actually cause these mice to develop their own version of Alzheimer's disease where they have beta amyloid plaques and something mimicking those neurofibrillary tangles that build up in their brains as they age. What they found in one of these studies was that for mice that had widespread beta amyloid in their brain, so much like somebody with Alzheimer's disease, they found a 3 to 4 times higher concentration of lithium in the regions of the brain with the amyloid compared to the non-plaque regions. Okay, so that's very much replicating what they saw in the humans. The amyloid seems to suck up the lithium and robs the other areas of the brain from it. However, this was dependent on age, right? So that effect was seen in mice that were alive for 12 months, which is a long time for them. For the same type of mice, but only at 3 months old, this effect was not there, and that's because the amyloid had not yet built up. For those 3-month-old mice, they had the same levels of lithium as compared to wild type mice, so mice that are similar to what you would see in the wild. So this indicates that as the plaque develops, as that amyloid builds up, it starts that process of robbing the lithium from the other parts of the brain. Since we're now in real experimental territory, right, you can't give a human Alzheimer's disease. You can't rob them of vital nutrients and cause them problems in a research study. With mice, for better or for worse, you can. So one of the things that they did next was they removed lithium, or at least reduced it from the diets of these mice to see what happens to them. Basically, they had 3 different types of mice that they looked at for this. They had mice with Alzheimer's pathology that's driven by amyloid, the plaques that we've been talking about. They had mice that had Alzheimer's pathology driven by tau and those neurofibrillary tangles. And they had mice with, no pathology, wild type mice, the same that you would see outside in the world. After they removed lithium from their diets, in both the amyloid and tau groups, they saw an increase in either plaques or tangles in the hippocampus, which is basically the memory center of the brain in those mice. So that means that intentionally reducing lithium can cause those things to happen. Just like the humans, we want to see what the practical effect of that is. So after they did that reduction of lithium, which caused the buildup of plaque or tau tangles, then they ran them through a cognitive test for mice. Yes, they have them. It's called the Morris Water Maze, and it measures learning and memory in rodents. It also measures some other things like swimming ability and things that are not related to memory. The results of this rodent cognitive test really mirrored what we saw in the humans. The lithium deficient mice had reduced learning and memory, even though it didn't impact other skills like swimming ability. So this suggests that the normal balance of lithium that gets disrupted is one of the drivers of memory loss with Alzheimer's pathology. We didn't know this before, so this is actually really, really interesting research. Now, the part that I'm not going to fully get into here is they looked at the transcriptome and the proteome, which are basically the complete set of RNA and the complete set of protein within cells of the brains of these mice. This is very, very advanced stuff. And they looked at that to see what the impact of lithium was. And they found similarly astronomical results. The highlights are they found that lithium was involved in many different processes, including inflammation, including the protection of the myelin sheath on neurons, so many different things that are involved in the normal, healthy functioning of a brain. So if you want to read that part, go to the study itself. It's a whole huge section in and of itself. So I'm not going to go into that here, but they found even more impressive stuff in that part of the study. Now for us, the most exciting part of this is they seem to have developed something of a treatment for these mice in this study. Since they showed that decreased lithium disrupts the brain's ability to function properly in terms of memory and other cognitive skills and drives the pathology that we see in Alzheimer's disease, the question was, if you increase lithium, does that help in some sort of way? It seems simple enough, right? Just increase the lithium in your brain and see what happens. Well, not so fast. Remember, lithium is getting bound up by the amyloid plaques. It's not getting to the parts of the brain that need it. So how do you prevent that from happening? And this is just so cool. The researchers had a hypothesis that it was the electrostatic interaction of the lithium ions and the beta amyloid deposits that were causing that binding to occur. So the researchers looked at 16 different lithium salts to see which ones were more ionized or more conductive, meaning they're going to be more likely to stick to the beta amyloid plaques, and which ones were less so. Interestingly, lithium carbonate, which is the kind of oral medication you take for bipolar or other times when you need a mood stabilizer, was very conductive, highly ionized, which means it probably gets sucked up by those beta amyloid plaques pretty easily. On the other hand, lithium orotate had the lowest conductance, so that was chosen as the lithium salt to compare with lithium carbonate in the experiments that they run. For the experiment, they administered 3 different things to the mice in their drinking water. They administered lithium carbonate, which is the medication version of lithium. They administered lithium orotate, which is the new version with the low conductivity that they want to try out. And then they administered a control, which was sodium orotate, which is essentially just water. And the results here were so crazy. So lithium in general was elevated within the amyloid plaques for both groups. Obviously, it's going to absorb some of that. But only within the lithium orotate group, this new thing that they're looking at, was there also an increase in lithium in the surrounding areas. So the areas that are normally robbed by the amyloid plaques had an increase in lithium, which is exactly what they wanted to find. And then when they increased the dose to a more therapeutic level, the administration of lithium orotate actually prevented almost entirely the formation of those amyloid plaques or neurofibrillary tangles, which means they prevented the pathology that normally leads to Alzheimer's disease. Again, this is in these mice, but holy crap, that's pretty amazing. I'm going to put some graphs on the screen so you can see this, but there's some visualizations where it actually shows the difference between the water control group, the lithium carbonate group, and the lithium orotate group. So if you look at the ones that say LiO, those are different concentrations of lithium orotate. Notice how few green spots there are in the amyloid plaque side and how few red spots there are in the tau tangle side. That means that that is actually preventing the buildup of those things, whereas for water and for lithium carbonate, it's fully present there, as you can see. Again, groundbreaking research, really, really amazing stuff. But that's not all. Even more impressively, they looked at whether supplementing with lithium orotate could actually reverse pathology in mice that have already grown up and have a buildup of amyloid plaque in those tau tangles. So for mice that had abundant, widespread beta amyloid deposits, the administration of lithium orotate, actually giving it to them in their drinking water, reduced the burden of that plaque, how much was there, by up to 70%. It's crazy. This effect was also present for cognitive performance. So for mice that had memory loss caused by the amyloid deposits, even the lowest dose of lithium orotate almost completely reversed the memory loss, according to that cognitive test we talked about earlier. And as if that wasn't enough, it also showed that it prevented structural changes, inflammatory changes, and other key effects that are known to contribute to Alzheimer's disease. The final cherry on top, as if there wasn't enough here, is that at no point in the study did they find a level of lithium orotate that was toxic to the mice. So it was really well tolerated and didn't cause other side effects. Okay, so what does all this mean together? I'm trying hard not to get too excited about these findings. Obviously, the research design is phenomenal, but in terms of the implications of what it really means, I need to be careful not to just latch on to one ray of hope. Given my background, obviously I want to find some preventative measure or some sort of treatment for Alzheimer's disease. But we do need to recognize transgenic mice are not humans. Right? We don't yet know the impact of using lithium orotate as a supplement in humans with Alzheimer's disease and similar pathologies. But if the eventual human trials that I'm sure are coming look anything like this research with the mice, holy crap, that's going to be groundbreaking, like Nobel Prize groundbreaking. Just to review, here's a few things that we know from the study. We know that lithium plays an essential role in cognitive functioning in humans and in mice. When it's reduced, it leads to impaired cognitive abilities. Beta amyloid plaques, as you see in Alzheimer's disease, steal the lithium from other parts of the brain that need it. Lithium carbonate is more attracted to beta amyloid plaques than other lithium salts like lithium orotate. And in mice, supplementing with lithium orotate can improve cognitive functioning and reduce the impact of Alzheimer's pathology. Please be responsible with this knowledge. Do not change anything without talking to your doctor. But it is fascinating to know that there are actually communities of people out there, as I was researching this, like on Reddit, there are various subreddits with people who have been supplementing with oral lithium orotate that you can find online over the counter for cognitive functioning. And so this is one of those situations where we see kind of convergence of people stumbling into things that help them and research verifying that there are some significant impacts to a given substance. So I'm very excited. Let me know what you think. If you have any corrections to what I said, if you have any questions about what I said, please leave them in the comments below or shoot me an email. And yeah, I'm going to go calm down now.